Hello all, welcome to the next topic from electrostatics. So electric field due to a finite conductor. So lot of things we have studied in the last few sessions also, and this is it's not come to an end, still we have to move little more topics. So the next topic is, write down the heading, electric field due to a finite conductor. Electric field due to a finite conductor. So we already learned something related to finite conductor in the last videos also, and hope you remember these cases we have learned. For a continuous charge distributions, electric field due to a conductor or due to a wire of length L meter, and we are finding the electric field at this point, and this is at a meter away. So the electric field at this point, we got it as, hope you remember this equations, k lambda into 1 by a minus 1 divided by a plus L. So this is, we are finding the electric field due to a finite conductor. Finite means the length is measurable. So the finite conductor electric field along that line, this is the equation. Now then of course you will have a questions to me, sir, why then you are again speaking about finite conductor? Here the difference is that we are going to calculate the electric field due to a finite conductor, not along the line but at some point towards right side. It is not necessary it should be a center point, but it may be any point. So I consider this point. Here I am going to calculate the electric field due to this finite conductor. So we'll draw some lines to the end. We'll start the derivations. So this is along the line, and this is not along the line. This is at some point, not along this line, but at some point will be here on the right side or left side, both will be same. So we'll consider one point will be here. Here we are going to find electric field. So the distance from this conductor to this point is given as a meter. Okay, so what we will do normally to find out electric field for a continuous charge distribution cases, this is also a continuous charge distribution cases, something similar to your semicircle, your quarter circle, your arc. The same case will be here, but it's a straight wire. What we will do in a general principle, we'll always take a current element. A current element will consider, and we will say the current elements will have a charge of dq and have a length of dl. Okay, here what extra I am doing means I am considering this length is small letter L, and distance from the current element to the point where I am going to calculate electric field intensity is small r. Okay, so now you know, because of the positive charge electric fields are away from the conductor. So this angle is taken as phi, total angle, and here it is a small angle is subtending. If this angle is phi, then what is this angle will come? D phi. So we have an upper triangle and lower triangles were there. So for the upper triangles I am giving a value, upper triangle and lower triangle. Lower triangle downside minus theta 2, upside plus theta 1. Okay, why I am taking minus theta 2 means everything down negative, everything up positive, everything right positive, everything left negative. While we are talking about an arc also, hope you have remembered towards right and towards left. Left we have taken minus phi 2, right we have taken phi 1. Phi 1. So in their cases this is like a symmetrical structure. So phi 1 will be equal to alpha by 2 and phi 2 is equal to minus alpha by 2, and this is plus alpha by 2. Hope you remember from the last sessions you remember how we have taken minus alpha by 2 plus alpha by 2, left right. Similarly here up and bottom is negative, up is positive. So theta 1 is angle made on the top side and theta 2 is on the down side, and the small current element makes an angle phi, and this element angle is d phi. Now you we are going to do the normal procedure. Electric fields are away from this point because it is positive. So this electric fields are called DE, and this electric field is because of the DL current element. So we are splitting, as I told. In physics, if everything on the x-axis and everything on the y-axis, it is easy for us to solve it. But here it is not on x-axis, not on the y-axis, so it's difficult to solve for us. So what we'll do? We'll do vector resolving. So this DE is splitted into two vector, horizontal and vertical. This angle is phi, means this angle is also phi. So what is this will come? DE cos phi. What is this will come? DE sin phi. So DE cos phi and DE sin phi. I can say DE cos phi is nothing but a parallel or perpendicular. This is perpendicular to the conductor. So this is a perpendicular electric field, and this is the conductor, and this is another electric field. So this I can say a parallel electric field, and this I can say an perpendicular electric field. So here we have two things will be here, perpendicular and parallel. Now, so two electric field we have to calculate, perpendicular and parallel electric field. So you will come up with some doubts in this case. Okay, anyway, you don't have any chance to ask doubts to me directly because of this all coronas. So what we'll do, I thought you may have some doubts, at least for few students, what you may think, like I'm thinking from your point of view, nothing else. Because of this all plus, some students may have some doubts. I have taken one, one point will be here, right, at a distance of a electric field. Then I told I have taken a current element. So electric field is like this one, DE. The same thing I am writing here. This is splitted into DE cos phi because this angle is phi, and this is taken as DE sin phi. Okay. So you can ask, or you can also may ask one questions to me. What is that? Actually, sir, here you are taken one current element. Similarly, you can take another current element will be here also, and you can draw one line like this one, and this angle is phi. If this angle is phi, then you can write it as DE. Here also you will come up with the DE cos phi, and you will come up with the DE sin phi. So DE sin phi are opposite and equal. So DE sin phi will get cancel each other. You may ask like this one. So DE cos phi will get added up. DE sin phi will cancel each other, means go out, 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 out. This is out of the scope. You can ask the same concept we have done while we are deriving about the semicircular wire also, right? We are taking two components, DE cos phi, DE sin phi, and we told along the positive x-axis DE cos phi will be there, along the negative x-axis DE sin phi will be there, both will get cancelled. So that's all. So the same principle you may think like we can also apply here, but that is a wrong concept. We cannot apply symmetry. Why I am not applying the same concept will be here also. Here I am sure that I have to take perpendicular electric field, I have to take parallel electric field. The parallel electric field, the top and bottom will never cancel. Why? Because the point in which I am going to calculate the electric field intensity, I have taken a point randomly on the right side, not exactly at the middle. If it is exactly at the middle only, this value will get cancel each other. So the point, it's a random point. So theta 1, the top angle is theta 1, bottom angle is theta 2. Theta 1 is not equal to theta 2 because I have considered some random point. Then you have a doubt, then okay, theta 1 is not equal to theta 2, then why phi top side I can take a phi angle, same phi angle I can take it at the bottom side. That is correct. You can take the same angles will be there. So in that case this will be get cancelled. But for all the components of DE sin phi which is going upside will not cancel with all the components at DE sin phi for this scenario, because this is a random point. If it is exactly at the middle point, let me take an example. Now this is a conductor, correct? So for this conductor you are taking a middle point, so you have a correct. Now from the center point you can take any number of 5. So this is 1 5, 2 5, 3 5, 4 5. Suppose here how many pieces you have? 1 2 3 4 pieces. The same pieces you can draw 1 2 3 4. So 1 2 3 4. So each of these 4 pieces will have one dE cos phi, one dE sin phi. For the top, for the bottom also dE cos phi and dE sin phi. So this is now a symmetrical one. So in this symmetricity, all the dE sin phi on the top equal to all the dE sin phi on the bottom, and both will get cancel each other. But here the case is not like this one. Here the difference is that I have taken a point, but it is somewhere here. It is somewhere here. Now from this point it is at a distance of A. So how many divisions I can take? I can take enormous number of divisions. Suppose I have taken 4 divisions, 1 2 3 4. The same 4 divisions I cannot make it on the bottom also. So here 1 2 3 4. If I make it, for example, 4 divisions, 1 and 2 and 3 and 4, the 1 2 3 4 will have an angle of phi 1, will have an angle of phi 2, will have an angle of phi 3, will have an angle of phi 4. This phi 1, phi 2, phi 3, phi 4 is not equal to the all the phi 1, phi 2, phi 3 and phi 4 coming towards the bottom. It's not equal, right? The upside phi 1, phi 2, phi 3, phi 4 angle is not equal to the bottom phi 1, phi 2, phi 3, phi 4 angles. If that is not equal, you cannot cancel these components of dE sin phi which is going on top will never cancels with dE sin phi which is going on the bottom. That will never cancel because of the unsymmetry. Here it is a symmetry. In this case, if you have a 4 components on top, you have a 4 components on bottom, and magnitude wise are equal. Here magnitude wise are not equal, because here you will get, for example, dE sin phi 4, and here also he will get dE sin phi 4. This dE sin phi 4 is not equal to this dE sin phi 4 because the phi angle here and here it is different. So this will never get cancel each other. That's what I told. There is no kind of cancellation is not possible because it is not symmetrical, as like semicircular arc. It's not symmetrical. If it is not symmetrical, you cannot cancel, and if it is symmetrical, you can cancel. So this is purely an example of an unsymmetrical cases. Hope you understood. Okay. So let's continue this derivations part. So this is for your understandability. You may have come up with some doubt, or you may think like this one. That's what I put it in front of you. Okay, so let's move to the derivations. Now we have E perpendicular, E parallel. We have to find out E perpendicular also. So the total electric field will be equal to total electric field E equal to, let's take black color. Okay, red may be little not much clear to you. Okay, white with black is good. So E will be equal to integral of dE cos phi. Correct? dE cos phi. So here we have to find out what is called dE. dE is the electric field created by this current element. Tell me along with me. K into dQ into distance from this current element to this distance. What is this distance is given in the diagram? R. So it is R square into cos phi integral. Why we are taking integral? Because it's a small element. We have large number of elements will be there. To find out the total effects, we are integrating. The question is, what is the integration limit? From here to here we have to go. So minus theta 2 plus theta 1 is integration limit. Here R is not actually given in the question. Okay, this is R we have taken. In the real numerical problems, A value will be given and the total length of the conductor also can be given. Here, so R I have to remove. To remove this one R, I am taking a triangle cos phi will be equal to, from this triangle. So here I am considering a small triangle. Okay, so let's do the same way. So this length is L and it is a right angle triangle like this. So this length is L is marking here. This length is A is marking, and this is R, and this angle is called phi. So what is cos phi from this triangle? Adjacent side by hypotenuse. So cos phi will be equal to adjacent side A divided by R. Okay, A divided by R. From this one, what is R will be equal to? R will be equal to A by cos phi. We will substitute there. So what will we get? E will be equal to integral minus theta 2 to theta 1 K into dq divided by R means A square divided by cos square phi. So cos square phi will go to numerator, cos square phi. Okay, so we have to continue. Dq means what? Dq is a small current element. We cannot use it there, dq. So we have to somehow remove this dq. To remove this dq for a linear wire systems, what we have learned one concept called linear charge density, lambda equal to charge by length dq divided by dl. So dq we can replace with the lambda dl. We are replacing here. So electric field E will be equal to integral minus theta 2 to theta 1 K into dq. So K into dq means lambda into dl whole divided by A square into cos square phi. A square into cos square phi. Now dl is a current element that is also not given in the question normally. So dl is a value in which we have taken as a current. So we have to remove dl will be there. So how we can remove this dl parts will be here. We'll take another system, another trigonometric relations from this triangle. What is tan phi? Opposite side by adjacent side. Opposite side divided by adjacent side. So opposite side means what? dl. Adjacent side means what? Opposite side means L. Adjacent side means A. Okay. So opposite side L, adjacent side A. Next we are taking L will be equal to tan phi into A. So I'm just differentiating dl by d phi. Why I'm differentiating means I have to remove the dl. dl is not actually, it's not in the real numerical question for entrance examination. They will give you the value of A. They will give you theta 1 and theta 2. That's all. So dl by d phi will be equal to, what is the differentiation of tan phi? A into sec square phi. Tan phi into differentiation A into sec square phi. So this dl we can replace will be here. So dl will be equal to A into sec square phi into d phi. We are substituting will be here. So the electric field E will be equal to minus theta 2 to theta 1 K into lambda into dl A into sec square phi d phi whole divided by A square into, one more thing extra will be here, cos square phi. This cos square phi will be here. Next, cos k lambda A sec square phi cos square phi. Okay, hope you have written this part. If you have not written, pause the video and complete your notebook till the last steps. I'll rub this area, then we'll continue from here. Okay, so you can pause the video and you can complete the notes whatever we have written so far. And while you are writing the notebook also, keep your open points so that we can discuss. Okay, so E is equal to minus theta 2 to theta 1 K lambda A sec square phi into d phi cos square phi. So I'll just write the steps again to have a better clarity. K lambda A into sec square phi and cos square phi d phi whole divided by A square. What is sec square phi into cos square phi? Sec square phi means 1 by cos square phi. So 1 by cos square phi into cos square phi, both will get cancelled, right? This will get cancelled. So what is coming? E will be equal to k into this. A will also get cancelled. So k lambda divided by A into d phi. Okay, k lambda divided by A into d phi. Here one mistakes we have done. Here we have a cos phi will be here, right? Here we have a cos phi. I'll take another color. Here we have a cos phi. So here we have a cos phi. This cos phi we are not carried will be here because r equal to r we are replaced a by cos phi. So a by a square by cos square phi. So one more cos phi will be here. So that I put it in the red color. So the same steps into cos phi. Here also one more cos phi. So the same cos phi will carry it here. So into cos phi. This cos phi. This is actually dE only we have solved it. Cos phi will be there throughout the equation from the first step itself. So here we have extra cos phi. Now what we have to do? The integration limit is there. We'll write the integration limit minus theta 2 to theta 1. Here also minus theta 2 to theta 1. Now the common terms will take it out of the integrations and we are integrating this one. So common term we are take it out of. So continuing the steps, E will be equal to k lambda divided by A into integral minus theta 2 to theta 1 minus theta 2 to theta 1 cos phi into d phi. Okay, this is the final step. Cos phi into d phi. So what is k? So k lambda divided by A. What is the integration of cos phi? Cos phi and integration sin phi. So sin phi theta 2 to theta 1. So we'll apply upper limit minus lower limit. So what we get? K lambda divided by A into sin of theta 1 minus sin of minus theta 2. Sin of minus theta 2 is minus sin theta. Sin theta is an even function. So what finally we got? K lambda by A into sin of theta 1 plus sin of theta 2. This is the real equations in which we are going to solve for. This is for electric field where perpendicular or parallel. We are starting with the dE cos phi, right? We have a dE cos phi like this one. We have a conductor like this with positive charges and we have a dE sin phi like this one. dE cos phi we have solved. dE cos phi, this is a perpendicular to the conductor. So this is nothing but a perpendicular electric field. And this is nothing but a parallel electric field. So now we have calculated perpendicular. So instead of E, I am writing E perpendicular. So this is the perpendicular electric field. So this is the perpendicular electric field created by a finite conductor. This equation is very important. Very important this equation. K lambda by A into sin theta 1 plus sin theta 2. Theta 1 and theta 2 values is given to you. You have to substitute in this equations. Hope you understood this area. Now we have calculated E perpendicular. If you are calculating E parallel also, how it will come? So the perpendicular electric fields we know and we want to know the parallel electric fields also. So perpendicular with the cos phi. Now if you are doing for parallel electric field, what's the difference will be here? Now if you see, if you look into this perpendicular last equation, k lambda by A into minus theta 2 to theta 1 cos phi d phi is coming. Because of this cos phi only, this red color thing which is carried from lower the first steps to the last step is coming. So that is coming extra. If you are finding parallel electric field, what will come instead of cos phi will be here? What will come? Sin phi. Sin phi will come here. So we'll do for parallel electric fields also. So let's wrap this area and we'll continue. So whenever, before I'm going to wrap this one, whenever you want to write a notebook, so keep it in, pause the video and then write the steps. So we are going to find out E parallel. E parallel. From here I am adapting the step. Okay, up to this it's same. So E parallel will electric field equal to k lambda divided by A minus theta 2 to theta 1 into sin phi into d phi. Tell me what is the integration of sin phi? minus cos phi. Integration of sin phi is minus cos phi minus theta 2 to theta 1. So k lambda divided by a into this minus, I have taken out of the integrations. So cos theta 1 minus cos theta 2, upper limit minus lower limit. Now I am multiplying this lower limit, this negative sign, into this bracket. So k lambda divided by a into cos of theta 2 minus cos of theta 1. This is nothing but what called parallel electric field. Now the point is like, in Neet entrance examinations or JE entrance examinations point of view, how the questions will be coming, whether the question is related with the parallel or question is related with the perpendicular, we don't know, right? So depends upon the questions we have to answer. So in our scenario, this is a current conducting line. We are going to find out electric field will be here. We are going to find out electric field will be here. If they are asking to find out electric field exactly at the center, what field will get cancelled? Exactly at the center, I told there are 5 1, 5 2, 5 3, 5 4 will be there for top, 5 1, 5 2, 5 3, 5 4 will be there on the bottom. Both will get cancelled each other. So if it is exactly at the middle point, then we have only perpendicular component. So perpendicular component exists and the parallel component is equal to 0 if it is exactly at the middle point. So if this is at the middle point, so this is the middle case. Okay, if it is not at middle, so what will happen? If it is not at middle means you have a conductor, you have some points will be here like this. Okay, then you have an angle theta 1 and theta 2. Here also you have an angle theta 1 and theta 2. This is theta 1 and this is theta 2, but you know theta 1 equal to theta 2 in this case. But here it's not equal. So what will happen? Perpendicular electric field will be there. That is there. It's not equal to 0. And E parallel electric field is there. That is also there. So both are not equal to 0 if it is an arbitrary point. If it is a central point, then perpendicular component is not equal to 0. Parallel component is equal to 0 if it is exactly at the middle. So you have to see where the question is asking. If the question is speaking about the exactly at the middle point, then the perpendicular component only exists, parallel component is 0. If the question is speaking about not at a middle point, some arbitrary point, then you have to be little more vigilant, and we have to see what you want to actually find out. You want to find out the parallel electric field or you want to find out the perpendicular electric field. Suppose they are not specifying whether you have to find out parallel electric field, you have to find out perpendicular electric field. They have given some arbitrary point and then they are asking you to find out what is the value of electric field intensity. What you will do? You have a perpendicular electric field like this. You have a parallel electric field will be like this. So parallel and perpendicular. How you will find out two vectors? Electric fields are two vectors. So how you will find out the resultant of the two vectors? Root of, many times we told, root of a square plus b square plus 2ab cos theta. Same formula will apply. The root of e perpendicular square. Tell me, if an arbitrary point is given, then you have to find out the resultant. Then what you will do? Resultant will be equal to root of e perpendicular square plus e perpendicular square, a square plus b square. You can take a any one and b another one. E parallel square plus. That's all. Next one is what? 2ab cos theta. Parallel and perpendicular. What is the angle between these two? 90 degrees. So cos 90 will goes to 0. So only this component, this is the total resultant electric field if the question is asking for any arbitrary point. If question is asking exactly at the middle point, then perpendicular electric field only exists, parallel electric field is 0. Hope you understood and you have written all the notes so far. Hello all, welcome to the next topic of electrostatics, and today we are going to discuss about the electric field at a point which is along the center of a semicircular ring. This is normally asking for your board examination also, and entrance point of view also. This is quite important. and we will learn some special cases also in addition to what you have learned through your textbook, and also we'll learn some interesting things at this end of sessions with some special cases. Okay, so let's move forward. So write down the heading: electric field along the axis of a ring. Electric field along the axis of a ring. Okay, so let's consider a ring in the sense this circle point will be a ring, and we are going to calculate the electric field along this line. So this is a ring. Okay, if you have some kind of bangles or something like in your hand, then here you have to imagine in a 3D point of view. If you have a ring will be here, then you are calculating along the central axis. Here you are going to find out the magnetic field. So here you have a circle like this. Circle is like this one, and here you have a here you are going to find out this electric field intensity at this point along the central axis. Okay, so we cannot draw a three-dimensional pictures will be here. So definitely if you are looking from your side, you can see only one side of the ring, but we cannot draw it in a two-dimensional pictures. So imagine you have a circle like this, and you are going to find magnetic field. This is circle, this is a ring, this is your bangle, whatever. So in the center point you are drawing one line, and you are going to find out magnetic field will be here. So this is a circle. So top of the circle is like this, and bottom of the circle is like this. So you are drawing two lines from the center point towards the top of the circle and towards the bottom of the circle. So you have a ring, bottom top side line and bottom line, and this is a center line which is passing through the center of the circular ring. This is what we are going to do. So let's move to the diagram first. So this is a circular ring. Okay, and this is distributed with charges, positive charge. So now next questions to you. This is a point charge or a continuous charge distribution. This is also an example of a continuous charge distribution, and this is ring, and we are going to find out the electric field intensity at this point from the center. Exactly from the center, this is at a distance of x meter away, and the radius of the ring is r. So what we will do for all the continuous distribution of the charge cases, while we are deriving the equations, what we'll do, we'll always consider a current element, then we will integrate, right? Same procedure we are following here also. Here we have taking a current element. A current element of current is with a dq amount of currents will be there in this element, and this element is at a distance of r meter away. So what is the electric field created by this current element? It is towards that or away from that. It is positive charge. So electric field is away from this electric field, and this is a dq create a dE electric field. Okay, now I am assuming this angle is theta. As I told in physics, if you want to solve anything, we cannot do it in between x and y axis. We need everything on x and y axis. So what we will do? We will do resolving of the vector. So dE is a vector, and we are going to resolve this vector into two parts: horizontal component and vertical component. So this is the horizontal component, and this is the vertical component. If this angle is theta, then this angle is also theta. As per mathematics, opposite angles are equal. So these angles are equal. So what we will do? Here we will get dE. This is a side nearer to theta. So this is called dE cos theta. This is a side opposite to theta. So this is called dE sin theta. Now my question is to you, this is a symmetrical structure or not a symmetrical structure with respect to this axis? This is symmetrical, right? The top to this line and bottom to this line, both are symmetrical or both are equal. So if there is a symmetrical nature will be there, then what will happen? Some component of electric field will get cancel it out, correct? So now here you have a provisions to take dq. The same way you also have a provisions to take a dq, and this dq will also create an electric field like this one dE, this angle is also theta, then this angle is called, this component is called dE cos theta, and this component is called dE sin theta. Symmetrical component, symmetrical structure. So there are components are there in equal and opposite direction. What all the components are equal in opposite direction? dE sin theta downward, dE sin theta upward, dE same, theta same, theta same. Both are equal component. Both will get cancel it out each other. So what is the only component which is existed? dE cos theta. So our net electric field, E net. E net will be equal to, how will do? Integration of total. We have to add everything. So we will get it as dE cos theta. dE cos theta. So while we are integrating, now we'll substitute for dE. What is the limit of, what is the value of dE? K. K is 1 by 4 pi epsilon 0. K into dQ by distance from here to here. It is given as r square into cos theta integration. Next, here we need to take it the things which are out of the integration, constant things. What are all the constant things will be here? K will be there, dQ will be there, r square will be there, cos theta will be. K is a constant, that you know. K is 1 by 4 pi epsilon 0. R is constant or not? R is constant. R is the distance from here to here. If you have a ring like this one, suppose you can assume this is a duster, this is a ring. So you have taking one distance R from here. You have to, because the ring is located like this. The ring is located like this. So you are taking R from here, R from this end, R from this end. All are coming towards the same point from different position. That's all. But the ring is placed like this. If you are looking from your side, then I can say, you can assume the ring is like this. So this is one line, this is one line, this is one line, this is one line. All are actually my palms. All are touching the different position of the ring like this. Okay, so this is one small letter R, this is another R, another R, another R, another R, another R. So all are actually my palm, and this end is representing this point. This end is representing E. Okay, so it is like this. You can consider this is my palm and this is ending at this point. So this is R, this is R will touch here, R will touch here, R will touch here. So R is constant or R is changing? R is constant because R is my palm length. This length, this my hand, this half of my hand length. So it is same. So R is constant here, K is constant, he will be here, theta. Theta is also constant. So theta is the angle made with the, theta is the angle made with this radius, this vector, this center vector. So the value of theta will be also will be getting same. So theta value is also same. Okay, cos theta. So it is a ring. Better while you are seeing this video, just to pause the video, and if you have some ring or some ball or some other structures, take it in a live sessions for this one. So ring. So now you can place it. This is a line of R. This is a line of R. This is a line of R. So this R is the distance from any point to that ring, and that is constant. Similarly, the theta value is also constant. Theta value means it is a line coming from the center. So this is one R. So this angle will be same. This is another R. So this angle will be the same. So the other edges also, you have theta, 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 you have theta. So all these thetas will also same in this case, and R is also same. So the same quantities will keep it in outside. So K into dQ by R square into integral. dQ is not constant. What is constant will be there in the numerator? Cos theta into dQ. Okay. So K cos theta, K cos theta divided by R square. What is the integral of dQ? Integral of dQ means Q, total charge. Q, differentiation integrations will get cancelled. Q is the total amount of the charge. So the formula is KQ cos theta divided by R square. This is the net electric field on the axis of a ring. These equations can be further modified. We'll see what is this R. R is an hypotenuse actually, right? R will be equal to R square plus X square whole power 1 by 2 root. Hypotenuse is equal to root of base square plus height square. So this R value we can substitute will be here. So balance I am writing here. We'll take another color and we'll go with one. So the net electric field can be further modified K into Q cos theta whole divided by what is coming will be here R square plus X square. Here it is square will be there, here it is root. So here it is coming as R square. So R square we can replace with the R square plus X square. Next, one more things, we are going to replace cos theta. What is cos theta from this diagonal? Cos theta means adjacent side by hypotenuse. So what is adjacent side? X. What is hypotenuse? R. So for this R also, R equal to root of R square plus X square whole power 1 by 2. So we'll substitute this one. So KQ into, now no cos theta, for instead of cos theta we are substituted. So R square plus X square multiplied with X divided by R square plus X square whole power 1 by 2. Whole power 1 by 2. Okay, here it is power 1, here it is 1 by 2. So what is the total value? KQX whole divided by R square plus X square whole power 3 by 2. This is the net electric field. Put it in a box. This is a net electric field. This is what you have seen in your NCERT or any other textbook. This is a value in which you have seen the total electric field will be equal to KQX whole divided by R square plus X square. I hope you understand these points. Okay, then now this is the derivations part what we are doing. Hope you understood. All the things will be getting R constant, theta, R constant, only dq is the only extra parameter which will be there, and which is only we are integrating. Rest of all the things are constant, even theta is constant, and R, this distance will be is also constant. So dq, q part, dq integrations q, and then we are simplifying, and finally we got E net electric field will be equal to KQX divided by R square plus X square whole power 3 by 2. This equations you have to remember, put it in a box while you are writing the notebook. As I told, always notebook is important. Whatever I am writing will be here, you have to copy it and you have to understand it, and then you have to write. Next, we'll move to some special cases based on this one. Okay, so the same heading will continue, and the continuation of this one I am writing here. Because of my less space, I'll write it here. Okay, so write down the subheading. Here will be here special cases. Special cases. I like case number 1. Special cases. Case electric field at the center of the ring. Electric field at the center of the ring. Electric field at the center of the ring. So electric field at the center of the ring means what? We are going to find out electric field at the center, not at the axis. So electric field at the center. So this is an electric field, and this is a ring of contains positive charges, and electric field at the axis at a distance of x meter away, and the radius is r. Then we know the formula will be here. What is that? The last formula. KQX whole divided by R square plus X square plus whole square 3 by 2. This is a formula. Next, here the case is like, what is the electric field at the center E? Okay, electric field at the center, what is the value? Can you tell me what is the value of electric field at the center? Electric field at the center means the point is at a distance of x meter away. So here, what is the value of x? We are at the center, we are not here. So we are at, so this point is now coming to here. So what is the value of x will be equal to? X will be equal to 0 in this case. So if you are substituting 0 will be here, what you will get? Electric field at the center will be equal to 0. Another theoretical explanation for this. One more alternate cases, not cases, like one more other way of explaining this I will tell you. In case of a ring, we have positive charges, we know, right? We already told based on the equation, if you substituted x will be equal to 0, then you will get electric field will be equal to 0 at the center point. Another way of explanation for this case, not based on equation but based on the theoretical concept. If it is a positive charge, this positive charge will create an electric field like this. And here also we have lot of positive charges. So this positive charge will create an electric field like this. So both electric fields are cancelled at the center. So what is the net electric field will be 0. The same case is applicable. This will create one electric field like this, and this will create another electric field in opposite direction, because positive charges are creating electric field on away from that one. So this electric field will cancel. Similarly, if you are taking this line, electric field coming into center and coming from the other end. So wherever you take, all the points electric fields are moving opposite direction and both are equal magnitude and they cancel. So that is another explanation for saying electric field at the center equal to 0. Here I am putting E suffix center to understand it easily. E suffix at the center. So one way of explanations, I told electric field at the center equal to 0 based on these equations. So this is one method I defined, and another method I have defined electric field at the center is equal to 0 based on the physics concept of electric field lines I have explained. And this is not sufficient for me, but for moving forward I want to give you one more concept from this one. Suppose if somebody will ask you, can you prove that electric field at the center will be equal to 0? You have three options. One option I told based on the equations. Second option I told all positive charges will create electric field away from the charges. So all are opposite and cancel each other. So electric field at the center equal to 0. Another equations I have to give what we have studied previously. So this is an arc. Hope you remember this from last sessions. This will create an angle of alpha degree. What is the electric field at the center of this arc? E is equal to 2k lambda divided by r. R is the radius. Sine of alpha divided by 2. If you are not remembering this one, please go back to your notebook and see we have written these equations before, right? So in case of an arc, this is in case of an arc, alpha is equal to 0. So if I am converting this arc into a full circle like this, if I am converting this arc into a full circle, in this case, what is the value of this alpha? Alpha means this total value. Total value is how much? 360 degree. Because full circle, the angle is 360 degree. So if you substitute alpha will be equal to 360 degree, what it will come? 2k by lambda into sine 360 divided by 2. Sine 360 divided by 2 is how much? Sine 180. What is the value of sine 180? 0. So which means now I have given to you three mode of explanation. Number 1 based on the equation, number 2 based on the concept, basic concept from physics, and number 3 based on what we have learned from the last class. I connected everything, all the possibilities I have connected, and finally we got three conclusions will be here. Electric field at the center is equal to 0. In what way I want to explain? Do you want to explain with respect to the electric field created at the axis of a ring? If so, I have an explanation here. If you want to explain the electric field at the center is equal to 0 based on the fundamental concept of electric field intensity, electric field lines are away from the positive charges. For a complete ring, one line will come like this, another line will come in opposite direction, both will cancel. Second explanation. And moving forward, I am also giving a third explanations to you based on what we have learned on the previous class. For an arc it is alpha, for a full circle it is 360 2 pi degree. So 360 will substituted, will got electric field intensity at the center of a ring will be equal to 0. This will ask for a true or false kind of statement, objective type of questions. Okay, electric field at the center will be equal to 0. So case 1 is over. Hope you have written this one. If not, pause the video and complete the notebook. I am moving forward to case 2. So what is about case 2? Case 2, it's nothing but I am going to find out the electric field intensity at a larger distance, not very shorter distance. So electric field intensity, electric field intensity at the axis of a ring. Electric field intensity at the axis of a ring for a long distance, I am explaining again. So we know it is a ring and the electric field intensity at this point x distance away is kqx divided by r square plus x square whole power 3 by 2. We know these equations, right? Next, what we are going to try find out, we have the same ring, but we are going to find out electric field intensity at a very large distance. X is too much large, very large. So if x is large means I have to say x value is much greater than the radius. Radius is small, x is too high. Okay, in that cases what I can r is a small value. If I am taking r square, a small value in the square, so it is further less, so r can be neglected here. So what we can write, kqx divided by r is small value in the square means too low, so r is neglected. So what is coming extra, x square 3 by 2, x cube, x cancels. So what is now the new electric field, kq divided by x square, kq divided by x square. Have you seen these equations before? Yes, you have seen. What is the electric field due to a point charge? Electric field due to a point charge, what is the equation of that one? Can you tell me, or can you remember that equations? We have seen, right? If we have a q amount of charge, this is called a point charge, and at a distance of r meter away, electric field will be equal to kq divided by r square. You remember this equation. This equation is similar to these equations, which means that what? At a very larger distance, very larger distance, the whole ring will act as a point charge. So which means, write down here, at large distance, the whole charged ring act as a point charge. This will act as a point charge. Why? Because this equation is similar to this one. Here it is r square, here it is x square, because x is very far away comparable to the value of the radius. These are the two special cases we have to learn based on this one. These two special cases are quite important for the NEET and JEE entrance examinations. Hope you clear with this one. Based on this, the questions will be coming. Okay.